Welcome back to Sugar. In this module, I'm going to review our research where we established the norms for the sugar method of transcription, collection, and analysis. So before we get started talking about the sugar normative sample, just so you're aware, the article was published in the July 2017 issue of Language, Speech, and Hearing Services in the Schools. So all of this data is also available in that journal article. When we started this study, we started with 385 children. The children were from ages 3-0 to 7-11. All of the children completed a hearing screening, the P-TONY, which is a screening for nonverbal intelligence, and the TEAM, the test for examining expressive morphology. In order to be included in the normative study, all participants had to pass all three of those measures. Then, for all of the kids that passed those measures, we had two seasoned speech-language pathologists give a subjective rating of 1 to 5 whether the child sounded definitely disordered, possibly disordered, typical, possibly advanced, definitely advanced. And all of the kids were rated as either being typical, possibly advanced, or advanced. And that resulted in a final sample size of 270 children. This slide shows you information about the race and ethnicity of all of the children who were included in the study. This information was based on a questionnaire that we gave to caregivers. So you can see 8% of the sample, the caregiver did not report any information. But for the other 91+% of the sample, the parent or caregiver provided information about the child's race and ethnicity. As you can see, most of the sample was white, but we did have almost 10% of the sample was Black or African American, and nearly 8% indicated that the child was multiracial. We broke kids into age categories using the same age categories that the team uses. So the age categories are 3-0 to 3-5, 3-6 to 3-11, 4-0 to 4-5, 4-6 to 4-11, and then 5-0 to 5-11, 6-0 to 6-11, 7-0 to 7-11. And this slide shows you the breakdown of males and females in each of those age categories. So how did we do this study? Well, all children completed the hearing screening and the P-TONY first. And once they passed those measures, then the children either did the standardized test of language, the test for examining expressive morphology, or the language sample. And it was randomized, so some kids got the language sampling task first and some kids got the language testing first. For the language samples, all children did a 10-minute language sample, but we only transcribed the first 50 utterances using the sugar methods that we have previously described. Then we calculated the 4 sugar metrics. So sugar MLU, total number of words, words per sentence, and clauses per sentence. This slide shows you the mean and standard deviation for each age group for the MLU sugar measurement. Again, this data is also available in the journal article. This slide is showing you the comparison of our data, which is the top line in red, to the Leadholm and Miller data from 1992, the Rice data from 2010, and Brown's data from 1973. And you'll notice across all age categories, our MLU values are higher and they continue to climb all the way up into age 7 to 7-11. And we think there are 2 reasons for that. Number 1 is that fact that we're using a robust conversational sampling procedure. So even though we don't have a scripted task, we are incorporating those elements into a conversation that allow the child the most opportunities to produce their most complex syntax. The other reason that we feel our data, our MLU values are higher is also because of the fact that we count morphemes that the other methods of analysis have not counted. And so, especially for older kids, it gives them credit for morphemes that they're using. This slide shows you the mean and standard deviation for the metric total number of words, and that's disaggregated by each age category. So you can see across all the age categories, the numbers continue to climb. This slide is showing you the comparison of our data for total number of words to the Leadholm and Miller data from 1992. And again, you'll see that our values are higher and that they continue to climb as children get older. Again, we think this is probably because of our concentrated effort to have a robust language sample. This slide is showing you the mean and standard deviation for words per sentence for each age category. And you'll see as children get older, they continue to have more words per sentence. This slide is just a graphic representation so you can see how words per sentence changes with age. We couldn't find any other data in the literature with which to compare our data, so this is just showing our data. This slide is showing clauses per sentence, and again, those numbers continue to climb as children get older, so this gives you the mean and standard deviation for each age category, and as you see, it continues to climb as children get older. This is just a visual representation showing you how clauses per sentence changes as children get older. Similar to words per sentence, we couldn't find any data in the literature with which to compare, so this is just representing our data. Finally, in addition to calculating the metrics, we kept track of how long it took to collect the sample, transcribe it, and analyze it. First, we did the full 10 minutes. So we calculated these time measurements based on the 10-minute sample, and then we added in the average time to transcribe and analyze. And that average was 25.3 minutes. But we also realized that not every child took 10 minutes to get to 50 utterances. So what we did was we went back for each of those 270 samples and noted the time at which the child produced the 50th utterance. And what we found is the average time was 5.63 minutes. So on average, children produced their 50th utterance 5.63 minutes into the sample. And when you add that then to the average time to transcribe and analyze, the average time is 20.91 minutes. So about 21 minutes for a typical child to produce 50 utterances, so for you to collect, transcribe, and analyze the sample, which we think is pretty good. We do admit these are typical kids, so we don't know what this time would look like for children with language impairments, but at least this gives some evidence to clinicians that language sampling can be a very time-efficient process. So if you remember back to Module 2, in our survey showed the number one reason SLP said they don't use language sampling is because it's too time-consuming. We hope that with a spoonful of sugar, it really will help your sampling go round and that you will be able to do language sampling in a very time-efficient way.